I'm going to try to do this whole video without having to edit it at all. So we'll see how that goes because I want to go to bed. So this assignment is going to introduce you to JavaScript, and of course it's optional. If you choose to do the card game assignment in Java, that's totally fine, but if you want to do JavaScript, this tutorial is to show you the basics of JavaScript. So the first thing you need to do is download the file I've provided for you. So if you click on this link right here that says JavaScript Basics.html and then click download, then it appears down here. Let's just open it up in the Finder so you can see it. Let's right click on it and run it with Google Chrome. There. So, as you notice, this HTML page doesn't have anything on it, and that's because I'm doing everything in the console. And you might wonder, well, where is the console? If we go to Developer Tools, it'll be a little different on a Windows machine, but I think you can do Control-Shift-J, and it should open up the Developer Tools. Might open you directly to the console. Anyway, so now I have the console open, and you should still see nothing. It should just be empty. And that's because if you look at the actual HTML file, let me go back up to it. Oops. No. Here we are. If we open this with a text editor, you can see there's really nothing here. I mean, there's a lot of stuff here, but I've commented it out, and I'm going to uncomment it piece by piece so I can show you exactly what it's doing. Unlike in the other projects where I've made you type everything, in this one all you have to do, or in this tutorial at least, all you have to do is follow along as I uncomment parts of these and make sure that you understand why it's working. Okay? So if we look through here, lots of commented code and very little actual code that is being executed. I guess the first thing I could point out to you is an HTML file begins with an HTML tag and ends, oops, I didn't even do it correctly, with an HTML tag. Let me save that. And then if you want to put JavaScript inside it, you have to embed or nest, I guess is a better word, a script tag. So opening script tag and then a closing script tag. And then inside of there we can start writing our JavaScript syntax or JavaScript code. So if you remember in Java or in another language, most other languages, there's something called a main function, and it's basically where your program starts. In JavaScript, usually, and other scripting languages, there isn't a definitive way to start it, because sometimes a lot of the scripts will just rely on buttons being pressed or other events happening. So, because a lot of times JavaScript is just used to accompany a graphical user interface, such as a web page, right? So one thing we can do to mimic the functionality of a main function is create a function called window.onload, because that function gets called immediately when the page loads. So we can define that function as follows, and I'm going to first uncomment this piece. And as you can see, the only thing here that's going to execute is the line console.log hello world. So let's save this really quick and then refresh the page. So click refresh, and then voila, right here in our console we have the output text, hello world. Okay, that's obviously the start, or that's how you start any new programming language. You learn how to output the words hello world. Alright, next let's uncomment this part. You'll see we're learning how to use variables now, and in JavaScript every variable begins with the type var. It doesn't matter if it's a string like a text value or a number value. They're all just vars, and it knows how to store each data type. You don't have to specify that. So You can just say var first name equals Paul, for example, last name equals Soderquist, and then I could log to the console. I could display some output. Just like in JavaScript, you could append some text to these variables, and it's going to print out the values these variables hold right where I have them appended into this other text. So let's run it again. Well, first let's save it. Make sure to save it every time you refresh it. And now when we click refresh, you'll see we still have the output from our previous run right here, but now it started over again, so we get hello world, and then my full name is Paul Soderquist. In 10 years, I'll be 36. And of course, the in 10 years, I'll be 36 uses a variable called age I created, and I gave the value 26 to. All right, let's move on. Now we're going to learn how to do the if statements, conditional statements, or decision statements. So in order to do that, I've created a variable called user age. So we're assuming there's somebody using this program, and they're trying to determine whether they're able to create an account. So let's say that the value, the age of this user is 12, and so it's going to check that condition, whether the person's age is less than 13. If it is, it's going to say it's too young. If it equals 13, it's going to say, wow, you're barely old enough to create an account. Otherwise, obviously, it's old enough, so it'll just say the user can create an account. And the next thing that's going to show, I'm using a couple other variables, one called guest height, one called guest weight. So this is like you're at an amusement park or something, and there are rides where you have to be a certain height, you have to be a certain weight, otherwise they won't let you ride it, right? So we're going to check the conditions here. As long as they're 60 inches tall and they're 75 pounds, then they can ride it. But otherwise, this is going to say, hey, you're too small if they weigh less than 60, or if they're less than 5 feet, or if they weigh less than 75 pounds. All right, let's just run it after we save it again. Refresh. And it should say all of the same output we've seen before, and this time it says the user is too young to create an account. And that's because, of course, the value of user age is 12, and it needs to be at least 13. Okay, and then the next output statement was the guest is too small to ride the ride, and let's check why that is. It says if guest height is less than 60, it looks like it is, right? 53 inches is less, so that's why it says the guest is too small. All right, those are if statements. Now let's move on to loops. Okay, so this code right here, the first part is just going to display the numbers 1 through 5. And then, well, let's just run it to see anyway. So if I save this, I refresh, and I see the numbers 1 through 5, and then let's just ignore this for now. Let's look back at the code to see what it is. So the rest of it, apparently it's going to add up all of the numbers 1 through 5. And then it's going to say the sum of all those numbers is, and whatever that sum total is. So let's just check what it said for that. It said the sum of all numbers 1 through 5 is 15. And if you do the math yourself, you'll find that that is correct. Good. Okay, let's go back to the code. Here I wanted to demonstrate what a while loop looks like. It's obviously very similar to other programming languages you may have learned. I'm using two variables here. One of them is a Boolean variable called earth is spinning, and it's set to be true. And I'm just going to check the condition. As long as the earth is spinning, it's just going to keep repeating all of this stuff. So it's going to say, yep, the earth is still spinning. The earth is still spinning over and over and over. And each time it's actually going to increase a counter I've created called board counter. Starting at 0, it's going to add 1 every time. And then at some point, if board counter gets up to 25, or above 25 actually, then it's going to output the statement, I'm bored of this loop, let's exit it. And it's going to break out of the while loop. Of course, that's a necessary thing to include because this is never going to be false. The earth is always spinning, and I don't ever change that variable's value anyway, so it's going to remain true. So I refresh. Oh, I already did that anyway. But yeah, as you can see, the earth is still spinning, and it says it outputted that 25 times. And then the 26th time it said the Earth is still spinning. I'm bored of this loop. Let's exit it. Okay. Moving on. How to program modularly, which is a fancy way of saying how to write and use custom functions. So let's uncomment that part. And I've got two more variables here. One of them is input text, and I have the value. It's a sentence that says the vowels in this text will be removed. And then we've got another variable that's going to hold the return value of a function called remove vowels, where I pass in that input value, that input variable's value. And then it's going to log or output into the console what that finished product is, what it looks like without the vowels. So first thing I need to do actually is make sure this function exists. So let's go down. Right here is the function remove vowels, and right now it's commented out, so let's uncomment it and let's save it and refresh. And now the last line of our output is the vowels removed. As you can see, the vowels in this text have been removed. Alright, let's move on. Oh, and if you want to look more closely, more carefully at what this function is doing, you can see it takes in a value and it creates a new value that has nothing on it, and then it just iterates over all the characters on the input value. For the entire length of this input string, it's going to look at it character by character, and it just says, hey, you there, you character, are you an A, an lowercase a, an E, an I, an O, or a U? And if it's none of those, then it says, okay, we can add it. So in effect, it will add every consonant to this variable here called newString. And then when the loop is all done, it goes and returns that value back where the function was called. Right here. Gets stored there and outputted there. Awesome, huh? Okay. Moving on, another function. Actually, no, not a function. We're moving on to lists. So in JavaScript, there is no concept of vectors or array lists. It's just one. It's just a list. You don't have to think of two different types of lists, really. Like in Java, you have an array and an array list. In JavaScript, it's just a list. And the syntax to create a list, very easy. You just make a variable and instantiate it or assign it to equal two square brackets. And that's going to create an empty list. And then you can add things to it by saying the name of the variable and then push and then put your values in it. So I'm adding all of the students that are in this class for the second year. If I've forgotten somebody, I'm sorry. And then I'm just going to iterate over that list one by one and output the name of each of those people by accessing them with that iterator value. Okay, so let's save that. And of course it should output all the names starting with Hayden and down to Daniel. Awesome. Okay, next let's uncomment this part. And I created another list here called numbers. And here's another way to initialize a list. If you don't want to have to push everything in every time, you could just create the list with the values already there. So I put in a 2, or I put in a 5, a 22, a negative 45, 9, 4, 108, 33, negative 78, and 103. Okay? And I want to find out which one is the highest. So I create a little function called getHighestNumber, where I can pass in that list called numbers, and then the return value is going to hold the highest number in there. And then I output that. Okay, so let's look at the function getHighestNumber. Scroll down here, and we have to uncomment it. And it takes in that list, starts with initial value, which is just the very first value it sees in the list. And it says if or well, it just says start out with the value you see in that first spot, but then iterate over everything, and if you find something higher, set that to be your new highest value. Okay, and then at the end of the loop, as soon as it sees every value, it returns that highest value it's seen so far, which of course should be the highest value in the entire list. Okay, so let's save that and rerun it. Go back to Chrome, refresh, and it says 108 is the highest value we've seen so far, or is the highest value in this list. And if you look through here, you'll see that that is correct. Feel free to change the numbers around and see if it continues to pick the right number each time. All right, now we're going to move on to something a little bit more in depth, but this is object-oriented programming. This is how you do more clever things with code than just something gimmicky that you would show your parents. This is how you actually write industry code and make lots of money. You learn to write great classes and use objects as much as possible. So let's uncomment this part out. And it says this is how to create and use objects. So you could create a variable called a Pokemon or whatever you want to name it, but then set it or assign it to equal curly brackets. That's going to instantiate an object, which means you can store things inside of it. So I can say things like, I can reference it by its name and create a data field called name just by saying its name, and then .name, and then I can assign that a value. I can create another one for a type and assign that a value. Anything I want. So I've specified the different data fields that are likely to be included in the Pokemon data object, such as a type, health, max health, attack, defense, speed, whether it's poisoned or not, whether it's paralyzed or not, and I've given values to each of these data fields. Okay, and I did that 3 times. I've got a Pichu, a Charizard, and a Haunter. And then after they're all instantiated, they're all created, I made a list of Pokemon by having the square brackets. Of course, that doesn't have anything in it. So I'm going to push each of the Pokemon into that list. And then, just to make sure it worked, I'm logging out the list of Pokemon. So I label it my Pokemon, and then I iterate over 4. Or I iterate over all 3 of these values. I iterate over all these values with a for loop. And I say what their name is by referencing which index in the list I'm looking at, which value, which element, and then calling its name by saying .name. Okay, so let's save this and refresh. And I should see my Pokemon, Pichu, Charizard, and Haunter. Okay, moving on. Now I've created another function called getRandom that takes a list of Pokemon and it'll just return a random element that it finds in that list. So it'll return one of the 3 Pokemon I've created. And then it's going to display some stats about that Pokemon, which of course is another function. So both of these functions, the one called getRandom and the one called display Pokemon stats, I need to uncomment. Include that one. I include that one. Good. So let's save that, refresh. And it looks like after it displayed the Pokemon, Pichu, Charizard, and Haunter, it said Pokemon stats, and it picked a random one, and apparently it picked Charizard. If you don't trust that it's actually random, just refresh again. And it looks like this time it picked Haunter. See? And then it displays all of the values that each of these data fields hold. And it says Haunter's poisoned, and we can go back and verify. When I created the Haunter, I passed in the value true for poisoned. So it is correct. Awesome. Let's look through a little bit more how the random works. It just takes in a list, and then it finds a random number between 0 and the last index of that list. Math.random gives me that random number up to that length. Math.floor just says truncate it, so if it's a decimal value like 7.3, it'll turn into a 7. If it's a 2.876, it'll turn into a 2. And then it returns the element at that position in the list it was given. And so that's how I got back the Haunter that time, and it was saved in random Pokemon. Then I was able to pass in Haunter into a function called display Pokemon stats, and that function takes in a Pokemon, and it just displays some information about them. As you can see, I've just labeled each of the text, or each of the data fields. And then I've got a little bit of decision making for the program right here, whether it's poisoned or paralyzed or not. It'll say, yeah, it's poisoned, or it's paralyzed, or it's okay. All right. Okay. That is objects. The very last thing in this tutorial is classes. Now, classes are a more sophisticated way to pass around more complex data. So we could just use objects. It would work. But it is better to create a class with clearly defined data fields, and then you can just call the functions of that class, such as the constructor, like I'm doing right here. I'm calling the constructor of a Pokemon class and passing in these values, a Blastoise, water, and all of these numbers that I've associated with each of the data fields in the constructor of the class, which I'll show you in a second. And then once that's created, I'm calling a function on the object itself called display stats. So before we go any further, we better look at the class itself. So let's uncomment this last part here. And you can see this is the way to create a class in JavaScript. There are a few other ways, but this is essentially how you do it. This is the most common way to do it. You define what the input values are when it gets created. You don't have to have any of these here, of course, but a good constructor should take in all of the values that need initial values, or that each of the fields need values for. All right, and then when they come in, I just say, hey, this object right here, assign a value that you got in that first parameter location called name. Assign that value to your own data member called name. And it's doing a couple things here at the same time. It's creating a data field called name and giving it a value. So same thing with type. It's saying, all right, create a data field inside yourself called type, and then store the value that I just gave you into that data field. And same thing with health, max health, attack, defense, speed, and whether it's poisoned or paralyzed. So those are all the data members, the data variables, class variables. There's a lot of different names for this kind of stuff. And then you've got your class functions, such as if you need this Pokemon to take damage in a battle or something. So there's a function I created called take damage, and it takes in an amount, assuming it's an integer, double, or whatever. It's a decimal value, that would still work. Just any numeric value, we can subtract that from the health of this Pokemon. Another function that might be useful is one called restore health. It would reassign a value to the data member for its health. It would just reset it to whatever the max health value is. All right, and then the last function I have here is actually just calling another function I have already created, display Pokemon stats, which you might remember from up here, right up here, right? So that does all the console logging. So I've created a function here on the Pokemon class that just calls an existing function outside of the Pokemon class. Anyway, so let's go back up here. Now that we've seen what the class itself looks like. We've seen how to create an object of that class and how to call a function on that class, such as displaystats. Let's just check and see if it works. So I'm going to save and go back here. And wait a second. Oh yeah, it looks like it is working. So this time, this is all the code. Oops. This is where it chose a random Pokemon, right? And it picked Pichu apparently. But then I created a new Pokemon called Blastoise, and with all these stats, and then I told it to display all the stats of the Blastoise. Okay. And just to make sure that our take damage function works, let's test it out. So we save it and refresh. But before we refresh, let's look at what our current HP is. Looks like it's 345 out of 345. When I refresh it, you should notice it went down to 297 because it subtracted, what was it, 46? 48 from its health. And then it displayed the stats again. Okay, let's check whether the restore health one works. So let's uncomment that, save it, and go back here and refresh it. And now you should notice it first displayed it as full health, and then it subtracted the 48. It was down to 297. And then we called the function and displayed again. We called the function to restore its health and display again, and it's back to 345 out of 345. All right, that is the end of this basic JavaScript tutorial. Good luck.